Hello everyone, welcome to Module 7. In Module 7 we'll cover sampling techniques and some of the basic principles of sampling. Your book does a pretty nice job of covering a range of techniques. I'll cover a lot of the ones that are in your book and a few that aren't, at least fairly briefly. And then I'll talk about some of the basic principles of sampling as well. So one of the basic ideas behind all of these sampling techniques is generalizability. If a research study is going to be used, its findings must be generalizable. And so what we discover about the few people that we can actually study must be applicable or should be applicable to the many people that will hopefully benefit from the application of our research. So if we're studying a sex ed program in a single school, hopefully the findings of that will be applicable to a lot of people who may get that sex ed program in the future or who are already getting that sex ed program. And generalizability is a function of how well our sample represents our population. And if you remember, again, your book has a nice diagram for what the population is versus the sample, and how we think about pulling the appropriate kind of sample from our study population, from the population, and from the universe. And so before we even begin, there are a lot of things that we have to think about and make decisions about. So the first is, what is our sampling element? So is it people? Is it school districts, counties, college campuses? And often for us, it's people. They're individuals in our sampling element. And then we have to think about, is that sampling frame accessible? So is there a list of all the members of a population that's available to you? And then we have to think about what type of sampling technique should be employed. And often the major decision that we're making is whether we're using a probability or a non-probability technique, and then which technique that we're going to use within there. And I'll talk a little bit more about this at the end, but it's also possible to combine different techniques. So we may have to think about all of the techniques and using them in isolation or in combination with one another. So if we're thinking about our sampling element, these are the things that we are collecting data about. They're often, for most social scientists, individuals, but not always. And a researcher can also choose different sampling elements to address the same overarching research question. So if our question is, does sexuality education decrease unintended teen pregnancy? We may be sampling individuals, maybe individuals within a school who get one of two kinds of sex ed programs, or those who get sex education versus those who don't. And we may look at individual sexual behaviors, knowledge about pregnancy prevention, their actual pregnancy incidence, so the number who get pregnant versus those who don't. But we also may be looking at a community as our element, so maybe school districts. Maybe some school districts have sex ed and some don't, or some have certain kinds of sex ed, abstinence only or comprehensive, for example. And so then our element may actually be comparing those school districts. And so we certainly get the behavior of individuals. We know the number of pregnancies, and those pregnancies happen to individual people. But our element in this situation is the school district and is looking at the mean number of pregnancy or the total number of pregnancies in a particular school district. So it's important to remember that regardless of our question, we may be able to get at the answer to that question in different ways via the kinds of sampling decisions that we're making. And a sampling frame is this exhaustive list, ideally, of all elements in a population, although often that is really not possible. So typically, perfect sampling frames often don't exist. So even if we're thinking about some of the older research in which people were using a telephone directory to try and get a sense of all the people who lived in a city. Not everybody is in a particular telephone directory. Maybe they don't have a phone, or maybe that doesn't capture people who are marginally housed. We don't necessarily know all the people who are within a household. So we don't necessarily even get everyone in the community, even with a method that we often think about as being a fairly good measure of a sampling frame. And probably not for individuals. We don't get this exhaustive list. So we may get an exhaustive list of school districts, hospitals, states, etc. And we also have to think about our ability to access these lists. So for some of us, depending on the positions that we're in, social service agencies, governmental agencies, things like that, we may actually have access to some lists that other people don't. But whether or not we can actually use that list ethically and legally is also a question. So typically we don't have access to an exhaustive list of all the elements in a population. So what are we going to do? So we often have to make compromises. Research in general is a whole series of making compromises. So we're often compromising in our sampling decisions, specifically between the need for the sample to be generalizable to the target population and the practical reality of obtaining sampling frames for that list of people. And we shouldn't be viewing sampling frames as either existing or not existing, or generalizable or not generalizable, but these are often degrees of generalizability. So some sampling frames may be more generalizable than others. You'll often see a section in the discussion section of a paper talking about the limitations of a study, and almost always the generalizability of the sample is brought up as a potential limitation of a particular study. And so we just always have to think about what that limitation is and how we have to temper the conclusions that we're making from our research based on that limitation. So again, the goal of any sampling technique is to ensure that our sample represents our population to the greatest extent possible. And I'll mention this again at the end, but all of these decisions should be coming back to our research question. We can think about all of these decisions as kind of the spokes on a wheel, and at the center of that wheel is always our research question. So what is it that we're trying to know? What kind of inferences are we trying to make? And then how do we make sampling decisions and create a sample that will best give us an answer to that question? So we're always coming back to that research question. So we'll talk about probability and non-probability sampling, and these are sort of big umbrella terms with a lot of different techniques underneath of them. So in probability sampling, all members of a population have some chance, or what's often called a non-zero probability of being sampled, of being selected. So this is random selection. And your book makes a really nice distinction between random selection and random assignment. Words that sound the same but are very different. So random selection is random decisions about who we will sample and who will be a part of our sample. Random assignment is after we select participants, and maybe we're assigning people to groups like a treatment group or a control group or different kinds of education groups, for example. And we always want to make sure, and we'll talk about this more in experimental design, that the people have both an equal chance of being in our sample and an equal chance of being in whatever groups we're setting up within that sample. So probability sampling employs random selection. It's advantageous for research because it reduces bias, or that's what it tries to do, is reduce bias in who is actually getting into your sample versus those who aren't selected to be in your sample. So simple random sampling is, in addition to having a non-zero chance of being selected, ideally each element of the population has an equal chance of being selected. So we may generate a list of random numbers. We may do fishbowl sampling, which is a less precise way of doing this. Your book talks about the random numbers list and the fishbowl sampling method. We may also do a systematic random sampling technique, which your book also covers, wherein we'll start with one random selection, putting our finger, on a random numbers table or something, and selecting every nth person thereafter. So every 9th person, every 200th person, depending on how big our sampling frame is. And this may reduce bias caused by some sort of systematic arrangement of a sampling frame. So maybe our sampling frame is listed numerically according to when people signed up for a particular program, or age, or alphabetical, or something like that. So this will help sort of correct for some of that. So with simple random sampling, this is obviously based on probability. So ideally everybody has an equal probability or some probability of being selected. And so based on what we know about probability and how, and the role of dice, essentially, people often use dice rolling as a way to demonstrate probability. And so chance shows no favorites. So your sample may be perfectly representative of a population, or it may not be. So for example, if your target population is comprised of 10% people of Asian descent, Your simple random sample may have 5%, 10%, 50%, any other number of people of Asian descent. And so even if you're using a simple random sampling or a probability sampling method, you may not get exactly, you may not get a sample that looks exactly like your population or is completely representative of your sampling frame or your target population. In stratified random sampling, we divide the population into various strata or subgroups. And then we randomly sample within these strata. So our strata may be geographical areas, race or ethnicity, socioeconomic class, gender, sexual experience versus those who are not sexually experienced. We can think about a lot of ways of stratifying that. And again, that comes back to our research question. Is it important for us to stratify in some ways, and if so, how? And so this may help make our sample more representative of the population if we want to acknowledge the fact that there are these strata or these subgroups, and it can also help us to control for the confounding effects of those stratification criteria. So if we know that gender impacts the relationship that we're looking at or the variables that we're looking at, then we can try and control for that by stratifying for that straight out of the gate. In cluster sampling, somewhat similar, but we're actually looking at clusters of people instead of individuals. So we may identify clusters within a population, counties, school districts, nursing homes, whatever, and then randomly sample the clusters themselves. So the sampling element again here is the cluster and not the individual. And again, as I mentioned before, we may gather data on the individuals, but only to the extent that they comprise characteristics of the cluster. In multi-stage cluster sampling, this can be useful when a sampling frame doesn't exist already for us. We can break the population into clusters, maybe even into subclusters, and then take a random sample within each of those clusters. So from this, we'll take random samples of subclusters, and then from this sample, take random samples of individuals. So this will help us to sort of develop a sampling frame in some ways when one may not exist for us already. And so those are the probability techniques that I'll cover in this particular lecture. In many situations, we're often engaged in non-probability sampling. So those previous techniques were all probability ones. It's not always possible to use a probability method. In fact, it's often very difficult to use a probability method. So these narrowly defined populations that we're looking at may not have sampling frames available to us, and random selection may be totally impossible or really ridiculous to try and think about. So for example, I recently conducted a study that was looking at young adults who drink and are sexually active in New York City. So obviously I'm not going to get a sampling frame of all young adults in New York City who drink and have sex. And so this is a situation in which a probability sample wasn't really possible. I'll talk a little bit about that study again at the end and some of the decisions that we made. So how might we get a sample of gays and lesbians, people who are disabled, rural African-American women, all sorts of different groups that we're looking at. It's really difficult for us to think of what that sampling frame might be. Convenience sampling is the easiest and probably most often used method of sampling. So if you look at a lot of sex research in particular is college students. And college students are great. They're a captured population in some way. We often request that college students engage in some sort of research for college credit, for course credit. And so this convenience sampling is often one of the most common ways that we're engaged in research. So this is sampling of a group of individuals that are identifiable and accessible to us. Accessible is one of the key pieces here. And so this bias may be introduced. These people may be self-identifying, or the most easily accessible respondents may not be actually representative of their larger group. So if we're talking about young adults, for example, college students we know are certainly not representative of all young adults. They may be representative of college students, and so if we actually are looking at college students, it may not be such a big leap for us to use a convenience sample of college students. And we always have to ask how significant this bias is. Is the study still worth doing this even with such limitations, or is the knowledge that we're going to generate from the study going to be useless to us if we actually have a sample that doesn't allow us to be able to generalize to some larger group that may be relevant for that research question. Purpose of sampling is targeting a group to be sampled. So we may actively seek individuals who are part of our population, people who are HIV patients, men with STDs, lots of groups that we can try and think about, as I mentioned before, young adults who drink and have sex. So it's a very purposive sample and way of thinking about who your participants are. If there is a group that already exists, like college students, for example, this may be the same as convenience sampling. Quota sampling is a sampling technique in which the researcher establishes some demographic group to be studied, and then we recruit those samples or that sample in order to obtain a quota of each group. So in a lot of research, we may say that we want to make sure we have equal numbers of men and women, or the numbers of men and women that match our target population. So we may want to make sure that we get roughly equal numbers of men and women in each of our classes, if we're going to go with the college student example here, which is a typical way of doing sex research. And so we can use other sampling techniques to get these people, but we may be trying to fill certain cells and make sure we have enough of these kinds of people. So in the study that I talked about that looked at alcohol and sex, we wanted to make sure that we got enough people who were under 21 versus over 21 because of the legal drinking age issues. We also wanted to make sure that we got we got a certain number of people who were of different races and ethnicities. We wanted to make sure that we had roughly equal numbers in some ways of people who identified as gay or lesbian or bisexual versus those who identified as heterosexual. So we may have a variety of different ways in which we want to think about quotas to make sure that we have enough people in a particular group to be able to look at whatever it is that we're looking at within that group. Snowball sampling is a sampling technique where we begin with what's often called a seed or an individual participant. And so this is an individual who's part of a population we're studying. We bring them in, we ask them to do whatever the research is that we're doing, and then we ask them to identify others they may know who are also part of this population. And then when those people come in, we ask them to identify other people that they know who are part of that same population, and so on, until we have a large enough sample. So this is, again, snowballing. With every wave, the sample gets bigger and bigger. And this may be a useful way to generate large samples of hard-to-identify populations. So, for example, injection drug users. This is a technique, this and another similar technique have been used with injection drug users because we often may not be able to identify those people. They may be people who are not engaged in social services, so we may not be capturing them if we're looking at social service agencies. They may not be engaged in other kinds of care situation. They may not be really readily willing to identify themselves as injection drug users because that behavior is illegal and stigmatized. And so this may be helpful for getting a large sample of people who are hard to identify or who are talking about a sensitive subject, for example. This can be very biased, and we also introduce some network characteristics in here. So if we get a certain kind of person as our seed or a certain kind of group of people as people who comprise that original group of participants, then we're probably only going to get people who are like those people. So we may have to think carefully about choosing a group of seeds who are fairly diverse to make sure that we get a network of people within each of those individual seeds or moving from each of those individual seeds that are diverse in some way. And so I'll stop here in terms of listing off some of these individual different ways of techniques. There are so many more. Your book in this lecture kind of scratched the surface of some of the more commonly used techniques. Some techniques that I've also used have been time-space sampling. So this is selecting venues. So for one of the research studies that I've worked on, we were interested in, the researcher was interested in different kinds of social networks and social venues. So, for example, he was interested in substance use patterns among different music groups and different social network groups. And so we looked at people at hip hop clubs, gay and lesbian clubs, indie rock clubs, EDM, electronic dance music clubs. And so basically what we did was we took then gathered information about all the venues in New York City that we could find who played EDM music, at least some night. All of the gay and lesbian clubs, all of the venues in which indie rock music played, and then looked at when those venues played different music, and then took a random sample of those nights when those clubs were open to us to generate the sampling frame that we were going to use. And then once we got to those venues, we used a systematic method of approaching people. So standing at the door and approaching every nth person who crosses a threshold, or every nth person who approaches the bar or goes to the bathroom, or whatever checkpoint that we're going to use. And so time-space sampling is a way of thinking about generating a sample of people who are specific to a time and place. Targeted sampling, which we talked about a little bit. There's a variety of methods within targeted sampling. Respondent-driven sampling is often thought about as a more systematic and thoughtful way of snowball sampling. Sometimes snowball sampling is called incentivized snowball sampling if we pay people to bring people in. Respondent-driven sampling is a situation in which every participant who comes in the door gets a certain number of numbered cards. And they can recruit their friends. They can give that card to somebody that they know who might be eligible for the study. And then if that person is eligible for the study and comes in and participates, then the referring participant gets, for example, $20 or whatever. And then within that method, you can also track the networks. And so you know who referred who, and you can be able to look at clusters of people and networks of people and be able to account for some of the characteristics of those networks. So in some ways, it was sort of originally, when it was devised, thought of as a more generalizable way to conduct snowball sampling, essentially. And respondent-driven sampling became very popular 10, 15 years ago and has kind of fallen out of favor again. It's, I'll have to say from experience, a very challenging way of getting people in the door. And I'll talk a little bit more about getting people in the door in just a second. And a lot of times people combine sampling procedures. So for example, using time-space sampling and a stratified sampling goal. So we used time-space sampling and wanted to make sure we got a certain number of people from each age category, racial and ethnic group, relationship status, etc. And so regardless of our method of sampling, whatever we're going to do, however we're going to sample those people, not everyone that we ask to participate will agree to participate or even respond to our request. So for example, in time-space sampling, when we went out to bars and clubs at 3 in the morning and approached people, this is what I did during graduate school to make money. We approached people and said, "Hi, I'm from Hunter College, or I'm surveying for a research study. Can I ask you a couple of questions to see if you might be eligible?" And some people would say, "Sure, great, let me talk to you." Some people would pretend like they could see through you. And some people would answer the questions and be like, "Yeah, no, I don't want to answer questions like that. I don't want to talk to you. I don't know." And so what we know is that people who agree to participate in research are different from those who refuse or who maybe don't even respond. In sexuality research, there's some evidence to indicate that those who agree to participate, when compared to those who refuse, have more permissive sexual attitudes, potentially more frequent sexual activity, and more sexual partners. Some research has identified that they are higher in sexual esteem. And so there are a variety of ways in which those people who actually participate may be different. And you can see the problem in this if we're conducting a large-scale research study and trying to make inferences about the larger population based on our numbers. And so we can say, like, look, young adults in New York City have X number of sexual partners. And that number may be an overestimate because we're not getting all the people who maybe had fewer partners who didn't want to participate in the research at all. So we always have to think about that and acknowledge that potential bias when we make the conclusions from our study and when we think about generalizing our results and making conclusions. So a final word on this, the technique that we choose will be a function of practicality. Who or what do we have access to? Methodology, what sampling technique will provide the most representative sample, and always, always, always our research question. So what is it that we want to know, and how do we think it is the best way to generate the answer to that question? And we always want to have accountability for all scientific research. So when we present the research, we have to present all aspects of our sampling technique. That must be really well spelled out. We want to include descriptive statistics about our sample to give our readers a sense of who we ended up getting. And we have to be honest about what our limitations are. And we all know that no sample is perfect. So every sample is going to have limitations. And we always have to think about what kinds of limitations are acceptable to us and what kinds of limitations are not acceptable. What kinds of limitations will prevent us from answering our question at all versus the limitations that may just be limitations in terms of maybe we can't make the kinds of conclusions or as strong of conclusions as we wanted to make, but we still have a fairly solid answer to our question. So again, we're always balancing competing demands when we're conducting research. So a quick word about sample size. I won't spend a ton of time talking about this. Your book does a pretty nice description of power and thinking about how to determine sample size for both qualitative and quantitative samples. I'll talk primarily here about quantitative. So we're always drawing a sample because we want to study some phenomenon in the population. And we use our statistical analyses to make inferences about the population. So this is what we found in our sample, and we're fairly certain that this is what's true in the population based on what we found in our sample. And so the sample size has a major effect on variance, and variance is often the core of all of our statistical tests that we're conducting. So greater sample sizes have smaller variance, and smaller sample sizes have greater variance. And so we're often making decisions about whether or not to reject a null hypothesis or fail to reject a null hypothesis based on the significance that we find. And the significance is often based on variance. And so all of these decisions sort of flow downstream from our sample size. And so we always want to make sure that we are statistically powered to find the effects that we're interested in. And power, in a nutshell, is a somewhat more complicated concept than I'm going to spend time explaining here, but power is our ability to detect an effect that is true in the world. And so this has to do with type 1 and type 2 error. But essentially, we want to make sure that our analyses or our sample are powered to find the effects that are actually true in the world. And so if we don't have enough people, we may not have enough power to do this. On the other hand, if we have a ton of people, we may find a lot of effects and have a lot of power to be able to detect effects that are actually very small effects. And so, again, we always have to think about the distinctions between statistical significance and actual practical, clinical, educational sort of significance in the world. But as your book demonstrates, power analyses are a key component of making sampling decisions. So anytime we're making our sampling decisions, we have to know how many people we're aiming for. And how many people we're aiming for will determine a lot of the practical limitations and will determine the kinds of sampling techniques that we want to employ to be able to get that number of participants. So in summary, the most important determinant of choosing a sampling technique is a selection of your population, and always our research question, always, always, always research question. So sampling needs to be a part of the initial planning process. This is not just a decision that we make sort of later on once we're getting ready to go and getting ready to start everything up. This is a decision that needs to be made very, very early on in the process. And there's no magical formula for sampling. We're always making decisions between a range of options that may have some pros and cons associated with them. And so again, we're always balancing these things. And so I think one of the tough things about research decisions is that there's often not a black or white, wrong or right decision that we're making. So we have to be creative, we have to have humility when we design and report on a research study and realize what the pros and cons of our decisions are. Again, I'll remind you that no study is perfect. We'll talk about this a bit more when we talk about analyzing a research article. But we're always, when we're thinking about reading studies, trying to assess what the pros and cons of each of their decisions are, and how those decisions impact what we find, what conclusions we can make from that, and how generalizable those findings and conclusions are. As always, if you have questions or thoughts, post those under the general discussion forum. Thanks.